So in lesson 9.3, we're going to talk about composite figures. We're going to use this definition of composite, something that is made up of parts. Look at the figure that's given to us. It's almost a rectangle, but there's this semicircular portion that's been deleted from it, a semicircle. And so what we want to do is we want to find the area of the shaded region. Now, if this was a complete rectangle, it would be as simple as 10 centimeters times 18 centimeters, and that would be 180 centimeters squared. But we have to find a way to erase off the semicircle, the half circle. And so the area of the composite figure is equal to the area of a full rectangle minus the area of the semicircle. So can we find the area of the semicircle? The answer is yes, if we can find its radius. Can we find its radius? Pause the video real quick. Think about it. Can we find the radius? Can you find the radius? The radius is easily found because the diameter of the semicircle, since this is a rectangle, is the same as 10 centimeters. And that means that the radius is equal to 5 centimeters. Now the area of a semicircle is equal to 1/2 pi r squared. And so 1/2 pi times 5 squared gives me 25 pi over 2. But what I like to do is I like to take 25 divided by 2. And so that gives me 12.5 pi. So that's the area of the semicircle. Okay, well, we know the area of a full rectangle. Length times width, that's 180 centimeters squared. And I also should put centimeters squared on the 12.5. So that means that the area of our figure, of our composite figure, is equal to 180 minus 12.5 pi centimeters squared. And that is the exact area to this. If you want the approximate, you're going to type 180 minus 12.5 pi into a calculator, and then you can round to whichever decimal place is appropriate. And so, okay, that's how you find the area of this particular composite figure. Now in this figure, this is a composite figure composed of a rectangle and a triangle. And while there are two different shades of blue, that's because of my Zoom program, we're going to consider the whole thing as one solid figure that's composed of two different figures. So I want to find the area of the entire figure. So to calculate this area, first of all, we know that the area of the composite figure will equal the area of the rectangle plus the area of the triangle. Now the area of the rectangle is pretty easy. It's 25 times 12. And so area of rectangle equals 25 times 12 feet squared. So 25 times 12 is equal to 300. So that's 300 feet squared. Now what we need to do is we need to find the area of the triangle. So I draw the altitude and I draw half of its base. Now, can you already calculate what half of the base would be? Half of the base would be half of 25, which is 12.5 feet. So now I have a right triangle, which means I'm going to use the Pythagorean theorem to figure out the unknown dimension, the height, the altitude. Once I have the altitude, it's 1/2 the altitude times the base. So let's do this. So I know that 12.5 squared plus h squared equals 14 squared. Subtract 12.5 squared to the other side. And then use the positive square root property. Since the altitude has to be a positive number, we use the positive square root property. And once we've performed that calculation, we will have the altitude. So I've decided, after calculating, to go to the nearest hundredth. And so this answer is going to be 6.30 feet is the height. And now we can calculate the area of the triangle. The full triangle. Area is 1/2 of its base times its height. Now the base is 25 feet. So 25 times the height, the altitude, which is 6.30. The units will be feet squared. So now let's go ahead and calculate that. 0.5 times 25 times 6.30. And so we get 78.75 feet squared. And now we have the area of the full composite figure. Area of the composite figure is equal to 300 plus 78.75, which is a very simple calculation. And so we finally see that the area of the composite figure is 378.75 feet squared. And there we go. We have the area of this new composite figure.